Hi, this is an example of what you can do with persistent save data. Let's hit play. Here we have an input box, a load and save text. We have a circle we can move around and a 3D object that's going to be locked to the circle's position. So as I move around the circle, the box takes up its position on screen. So the circle moves, the data is saved, the box reads the saved data and positions itself there. Also, we can enter in some text. We can save that text and we can reload that text. Let's see how this is done. Here we have our persistent circle. It uses the persistent reference component and it's recording its transform position. In this instance, we're saving in a bunch of different formats to this file name. So binary, JSON, and CSV. The files are saved to Unity's persistent data path. Here you can see a XML representation of that file, the last position. Binary format, of course, is hopefully unreadable. You have JSON format, and those are the three file types we chose to save. You can load back in any format, but you only have one. So for instance, if I want to load player prefs, I didn't use that as one of the save selections. So it's giving me a warning. So let's put that back to JSON. So if I hit play, my circle should return to where it was. And now when I start moving, the box would again begin to follow it. So the position in a mixed format being loaded back as JSON. So for the cube, it has a persistent notification component attached. Now, you drag in and add in the reference you want. You select the events you want to listen for, and they automatically load up the selections that we have. So here we're saving 3D vector, vector 3. So that's one of the options here. So if I was to add, for instance, another member, let's just make it the tag as a string, just so you can see the difference. So I also have here where I'm saving and loading the data, a string reference. We'll get to that string reference later. Let's remove this tag. So now I'm telling the system I want to be notified when data is saved or loaded from this component. And after the save, we're going to position its transform. So you can add any, for instance, we can modify the mesh renderer. These are all static parameters. So we use the transform to get a dynamic parameter. And we can save any 3D vector and load it back dynamically. And we use the position in this case. And that's the result, without having to write a single line of code. So now let's see what happens for the input. So the input persists quite a few things. The text, whether it's enabled or disabled, and it's inactive. But in this case, it doesn't use, you don't choose when the data is saved. It's manual, because auto is not checked. So that being the case, you need to save and load the data on your own. And that's what the save and load buttons do. So when we hit the save button, we're going to save the text, whether it's enabled and whether it's interactive, excuse me. And we'll be reading and loading data back in binary format. So the buttons themselves have a reference to persistent reference, and we're going to load and save the data. Now, there's a text box in here that shows what data was saved. So after we save the data, we have a persistent notification here again that's listening for these events. In particular, the text event. The text has been saved event. And that's pretty much all it takes. You set up these parameters, not a line of code required, and you can get some pretty cool things done. One thing I did not mention is that you can choose the file name or use the one that's given to you. So it goes without saying that file names need to be unique, because every chunk of data is saved within that specific file for that component. Cool. Now, let's see how this is done from scratch. Let's create a new scene. We don't need to save the changes. So let's go ahead and create a panel. Very simple scene. We need a input field. Let's go into 2D, make this a bit easier to edit. Let's add in a text and a couple of buttons. Control and D will duplicate that button for us. All right, so let's have a save button, a load button. Let's add in some load text and some save text. I'm going to be replicating some parts of the example scene we just showed to show how it's pretty much all done. So let's add the save here. Load. Here's our text field. Let's put that out of the way. And here's our input field. So let's start with the input field. Let's add in a persistent reference. So it needs a component that it's going to reference. Here it created a random unique file name that you can use, or you can rename it as you want. Input field data. That seems fine. So let's reference the input field on there, and let's pick some members to save. Let's just go ahead and save the text value. We'll save it in binary and JSON. That way we can read it in the folder path, and we'll load it back in JSON in this instance. So in the save and load button, we'd like to reference the input field and the persistent reference, one for each. So for the load, we'll be loading the data, and for the save, we'll be saving the data. So now the data is saved and loaded, and it will reflect into this input field. So let's go ahead and give that a quick test. So there's no data to load. Let's go ahead and add something. And let's save that data. Now the data should be saved. Let's exit. We can check quickly. Remember, our file name was input field data. So we can go in here and see input field data has been saved in JSON and binary format. Let's do a quick Sublime to make it official. And here's our data. I'm back. So now let's see if that data can be loaded back up. This is Unity's UI. It does that every time. So the data automatically loads right back into the field. So I can clear that and load it back up. The reason it presented itself automatically is because here we're saying on start load the data back up. So it's going to automatically load it and fill that field with the data. If we didn't want that to happen, we would turn off the auto, like I mentioned before. So now when I hit play, the data is not going to be automatically loaded or saved. We're going to have to specify that. And now I'm back. And it's that this simple to save and load data with persistent save data. Okay, so now that we've seen what it can do, let's go ahead and extend it and extend its capabilities. We're not going to create new capabilities, but we're going to see what the capabilities can produce. So here we have a scene, and we have a red circle that eats these green things and gets 10 points every time it does so. So I can move it around with the arrow keys. You see I have 0 points, and now I have 10, and now I have 20, and so on. I can reset my circle and or my points. So, okay, so let's end this on about 50 points. I'm feeling lucky. Okay. So we started up again, and as we see, we still have 50 points. Now there's something peculiar happening here. The data is being saved as an integer. And the data is being loaded back as a string. This is special functionality I've implemented just to produce this type of functionality in the software. So normally we would have a point system like this, and if I was to run this, it will surely update the field, but remember it's an integer. So all we will get is integer values out of that. So now that we know it's a string, and we know it's coming in and out as a string, if you know C#'s string format, you can use the first index to specify what you want to be marked as an index, and it would use the entire contents of the text field indexing what you request. And that's how we get the effect of the points being replaced and using the entire word also. Let's take a quick look and see how this is all done by the components. So again, we have a persistent reference that's named circle sprite, and we can take a look at that here. And here's our circle sprite. We have it in XML format here. Cool, interesting. Take a look. So this is, I thought that was XML I opened up. Hang on. Oh, that's CSV. My apologies. So here's a CSV representation. So that's the data, and it's being saved, in this case, in binary and CSV. I guess that was some previous data we loaded up there. And we're loading back in binary on start. So whenever the points change, then we have the text persistent notification that's listening for that. And of course, like I said before, it is an integer. So here's your dynamic int. But if you select the string, a text, we do some work in the background to have that translated into text form for you, so you can represent booleans and other data types that way. Cool. So that's how you can use persistent save data to load and save data without writing any code and have it presented in the format you want. As you can see here on my screen, I'm opening up Visual Studio. Persistent save data offers a no coding solution to saving and loading your data. But out of the box, there's only a few data types, the most common that's available. So API allows is for you, the developer, or the coding people on your staff, to create their own parsers that can save and load any data type imaginable. So for instance, this is how we create a color parser. We've seen a vector3 parser in use. It's as simple as inheriting from parser, overriding the save and load parse methods, and providing the functionality on how to save and load. It's all string format represented, so it's can be used across all data types without any conflicts. So here you can see for loading a vector3, we split the vector3 up. We separate the x, y, and z values, and we return that as a vector3. That's for loading. For saving, we grab the vector3, the object that comes in, we format it how we want to save it out. So in this case, we use string format for the first, second, and third indices respectively. First, second, and third IDs respectively, 0, 1, and 2 index. And we save out the x, the y, and the z. Now that's how any parser can be created. So here's our color. I chose to use this format to save out the color, and we present it this way. Right? And built in, there's other formats that come that are not represented here. So for instance, we have color value, and in the core system, we have Boolean, enum, and all the basic parsers. And like I said, you can create your own and use them as well. So that's for parsing the data coming in and out. You also have to format the data. So there's formatters built in, and we can take a quick look at those. So let's look at the core format. Formatters. So there's binary, CVS, you've seen those in action, JSON, XML. And here is an example of how to create your own. So for instance, a player press formatter. Right, you need the name of the file of type you'll be saving, and you create your own serialized and deserialized methods. So we send the data to disk or wherever player press puts the data. Right, we create the length of how much members we're going to be saving. We loop over those members, and we set the member data as the file key in the player press. So all the data is saved into the player press, any data, and loading it back is of similar fashion. So we get the string, player press string. So this getString method is just getting the string from the player press. You get the string for the name and the value, the type of data that we saved, whether it's a property or field. The index, which can change, but it's used in various places throughout when code is compiled to identify specific types of data. So you can create your own. If you have a different file format that you'd like to save your data in, or custom file format, it's, dare I say, not that hard. So that's how you create your own parsers and formatters. So that's it. Thanks again.